Hello, I'm Chad McGraw. I'm with Honeywell Process Solutions. I'm the SCADA and Pipelines Marketing Manager. I'm going to be speaking today on digitalization of pipeline systems. I spend most of my time looking at industry trends and technologies and then bringing them together into new solutions. First of all, we're going to be addressing what is this digitalization. We're very familiar with the digitization, which is really just converting data into a number that we can use and transmit in our systems. In our world, that might be a pressure sensor and transducer that comes into an RTU and gets digitized at that point. We then send that over some type of communications network to an operations center where digitalization takes advantage of that piece of data and many other pieces of data, and we present those onto a screen for a pipeline or pipeline controller or other people in our organization to take advantage of that information. Digitalization has been going on in our industry for a very long time, at least since the 1980s. Today, with over 8 billion devices connected to the internet, with 1 trillion expected by 2030. Digitization is about visibility and efficiency, bringing more value into our organizations. Today we're going to be talking about field networks, common HMI screens, alarm and asset management, safety, enterprise tools, digital twins, fewer but larger databases, and how do we get started on this path. First of all, we have to use our RTU or the field locations as our starting point. The field network involves our use of field instrumentation, bringing that into some type of controller, whether that is an RTU or PLC or other electronic device. It handles that digitalization. We have a number of protocols available. These are just ways to communicate from one device to another. I start with HART and wireless HART just because these are networks or protocols which allow us to bring in more data with fewer wires. In the case of HART and wireless with wireless HART. More of the newer RTUs and PLCs will be able to handle this additional data. Modbus TCP is a new version of a very old favorite, the Modbus serial that goes back to the early 70s. We have IEC 60870, which added security and history backfill to that. Both it and 61850 were led primarily by the power industry as they were looking to add security to the grid. 61850 and DNP3 added further security and efficiency. Using something we refer to as send on change with deadbands. The best way to reduce how much data that you're going to send is to not send it every time. With Modbus, if a value changes, we still send it every time. So if we want to pull at 5 seconds and it doesn't change, we send it again 5 seconds later. This clogs up our communications and adds data cost through our communications provider. 61850 and DNP3 will send a new value only if it's different from the last value. Now, on an analog system, we know that there's noise in the system, and there's always going to be some variance. So deadbands were introduced to further reduce the amount of data that we might be sending. If we don't need, 1 in 20,000's accuracy, we might be able to introduce a deadband and reduce our data usage further. I frequently recommend 1%. Some people that are looking to do analytics want to get tighter resolution than that, and that's good. We don't mind that. It's just that we're going to be putting more data across the line when we reduce those deadbands or increase our polling rate. So, for instance, many of you might be polling at 1 minute today. If you wanted to reduce that polling time, you're going to create more data. And some of these newer protocols will allow you to do both, where you can poll more frequently, but only send it if the data is changed. And I think we could all agree that's a win-win outcome. 61850 and DNP3 also add date stamping. So we're going to stamp all the information with a date stamp so that when it comes into our central location, we know exactly when it was created. And a history backfill so that if we lose our communications, we can go get that information once the communication lines are restored. So the RTU or other device will send all of the data that's been getting stored into internal storage once the communications are restored. And then finally, MQTT here at the bottom adds a broker in the middle. It's a what's referred to as a pub-sub protocol, where the RTU or other device is a publisher, and then multiple devices can subscribe to that data from the broker. So the data can be used by multiple parties without going through the SCADA system. Typically, this is read-only by everybody except the SCADA system, and things get pretty complicated fast if you're going to allow multiple people to write data at that broker level. Suddenly, your SCADA system will realize it's not in control, and it generally won't be happy. And the same for your pipeline controllers. But MQTT does offer some nice efficiency and a good way to get analytics data or data for analytics to third parties to process that data. The best example of MQTT is probably the weather app that we all use on our phones. All the different weather stations send their data once per time period. And then we all go in and use that data, but we get it from the broker. We don't get it from the weather station directly. So that broker is able to dramatically reduce the communications costs. This is a great way to go if you've got multiple people that you want to give access to the data. You just need to worry about security. Another form of field network is our metering skid, for instance. We can take advantage of new digital tools like simulation and virtual controllers to test that system out before it even leaves the manufacturing facility, even if the controllers are not going to be paired with it until they get into the field. So this gives us flexibility in our building our modular equipment and gives us options to meet a faster project timeline. Common HMI screens give our pipeline controller more visibility. We can incorporate multiple platforms into that one HMI device. We can reduce the number of screens that they're having to use, how much they're having to move around, and prevent overload for that pipeline controller in what can be a very hectic environment. Getting all of the data to one set of alarm screens, for instance, and then to allow other people, including engineers, managers, and your health and safety personnel, to access that data remotely. Digitization gives us a single version of the truth. Highly important in today's organizations where we have so much data and all that data is changing constantly, it seems. It is very easy for two people to come into a meeting with very different numbers for what they perceive as being the exact same thing. And that can be very frustrating for leadership to make decisions from. So as we look at those HMI screens, we can see here, some large screens. In this case, 55-inch screens. We use touch panels for the operator controls today to avoid physical touch of the main panels, eliminate that reach, but at the same time allow a dynamic touch panel which changes its capabilities depending on what the controller is focused on. One of the major ways that we put some sanity back into the pipeline controller role is to provide them a common alarm system where all of these different devices populate that one alarm menu and give them a consistent set of tools to acknowledge or to potentially shelve or dismiss different alarms. We have found that fewer screens with less color make their job much easier. Alarm management and operations management as well, along with asset management, all improve that process even more. We reduce alarms by 60 to 80%. We reduce controller overload and error because of that. The analytics that we're running help us identify what the pipeline controller needs to see and make sure that information goes to the right person at the right time. This improves safety and profitability. It allows us to stop reacting and start predicting where we need to put our attention. And then an example of this is an integrated alarm and asset performance data that we're able to provide today. And then to the right side, a cyber risk manager that looks at all of the different applications that are used in our organizations to keep our network safe, brings them onto a common dashboard to give ourselves a quick window into our situation in respect to cyber and physical security. One of the most popular items I find today is mobility. And an example of that is our inspection rounds product. This is software that works both in the back office, but most importantly, puts a really valuable tool into the hands of the field worker using their smartphone, tablet, and as well as our Honeywell intelligent wearables. Um, we can provide that person with a task list, effectively work orders in that language, visibility of prior readings, comments performed on work performed at that site previously on that piece of equipment, um, logs GPS coordinates, helps us find that pressure sensor along the pipeline. And if we do have to go offline because cellular network isn't available, it will go ahead and allow us to work offline, but then synchronize when we're back within range of the network. We've got many mobility tools. This screen is showing the Honeywell Forge for Workers, which is our inspection rounds here. And then on the right-hand side, our Experion SCADA system has a mobile app that allows us to look at any of the points in that system, points, tags, however you want to refer to them, and allows us to trend, alarm, and even provide feedback to the operators, controllers, what's going on. So one of the reasons mobility has been so popular is because it's used. Workers accept it, and they thrive on it. They have been looking for ways to eliminate the paperwork. These tools do that. In the areas of safety, these mobility devices allow that field technician to see for themselves what's going on in that piece of equipment. They can see pressure maybe isn't what they expect it to be. Maybe something a line was supposed to be cleared but has not been. They can see that on their device. This adds a level of safety and improves communication between the pipeline controller and the field. We talked about enterprise earlier, and these Honeywell wearables under earlier. We're using virtual reality and augmented reality to help people learn their job faster. Oftentimes we've got detailed but delicate tasks that need to be performed. Maybe we don't do those very often. These systems allow us to be live coached through a process by maybe a remote specialist, or to watch a video, YouTube or other, that might help us do the job better. And we have found it is a great recruiting tool when you bring candidates in into your organization. Digital twins have been around a long time, but are gaining popularity again as we've improved tools for keeping them in sync and updated. Digital tools are typically used for simulation and training, and in today's world we are using them to optimize the entire process. All of this data has to go somewhere, so We are focusing on fewer but larger databases. Fewer because we need our reports to be able to efficiently go out, combine data that is coming in from different points of view, whether it is your ERP system, your pipeline system, and potentially your maintenance system, bringing that data together and providing unique perspectives on that data. It's best if we can do that by using open standard databases and provide enough history that we can understand, what's happening at this moment in time. Finally, where do we start? First of all, we have to understand where we're at today, what we know about our systems, and what we do not know about our systems. In this regard, one of the areas that we often find missing, and generally get to this pretty quickly when we start doing leak detection, is we may not have the instrumentation that we might like to have. It all starts with efficient data collection, preferably from a standardized model template. We want to use the standardized model or template so that we can build it once and deploy it 1,000 times if necessary. And that also allows us to compare those 1,000 different devices and understand when one might not be working the way that it should be. We bring that information into or data into our database and process historian. We use machine learning tools and analytics along with business intelligence tools to analyze for ourselves what's going on, and then often pair that with cloud-based mobility tools. And I said cloud-based here because most of these mobility tools work best in the cloud, where they are connected to high-speed internet and major computing power. The mobility tools and analytics are well served by today's modern data center. But item 6, of course, probably the most important, is the cybersecurity tools and visibility, so that you understand when somebody's trying to penetrate your systems. Industrial companies today are getting attacked at far higher rates than ever before. It's amazing how fast a new connection starts getting pinged for potential penetration. And then the other part of where we get started is looking throughout your organization. Where can you eliminate steps? Where can you make people's jobs easier? When can you eliminate having to rekey data? Help your people to move your product from source to destination and bill for it in the most efficient manner. In summary, understand the problems you want to solve, learn from the successes and failures of others, avoid the black box approach because you can't afford it long term, invest in industrial strength cybersecurity, move quickly, stay agile, and don't be afraid to fail. Make the failures small, but don't be afraid of them, because that's how we get to our final destination faster. And then partner with somebody you can trust to understand the technology and be there 30 years into the future. We are constantly being asked to put proposals together to update equipment that has been out there and making money for 30 years. We expect the solutions that we do today to similarly, provide long-term benefit to you, the customer. So, find a good partner. Digital transformation is complex, but the benefits are worth the effort. I really appreciate your time today. Thank you, and remind you that the future is what we make it. Thank you.